To compare quantitative with quantitative, we use a scatter plot. But how do we describe this relationship? With direction, strength, and linearity. Let's take each of these one at a time. First, direction. This describes how the variable on the vertical y-axis changes as the variable on the horizontal x-axis increases. This scatter plot has a positive direction, as when we go from left to right, the points generally increase. The next scatter plot has a negative direction, because the points decrease when we go from left to right. Next, we want to examine the strength, which is how close to a straight line the points lie. This is described as weak, moderate, or strong. There's no strict definition of the boundaries between weak, moderate, and strong relationships, but roughly, we generally think of the correlations with magnitudes between 0.1 and 0.3 as being weak, between 0.3 and 0.6 as being moderate, and greater than 0.6 as being strong. You can compute the Pearson correlation in R using the core function. For example, if we wanted to compute the correlation between engine size and city fuel efficiency in the MPG dataset, we'd type this. To get negative 0.8, a strong negative relationship. Always be careful using the correlation on its own. It should only be used with a scatter plot. For example, take a look at this scatter plot. It has a definite relationship, which is very strong, but it has a correlation of 0. Correlation is all about linear relationships. You need to look at the data to see nonlinear relationships like this one. The final question we ask is the relationship best described by a straight line, what we call a linear relationship, or is there some curvature, a nonlinear relationship? In this scatter plot, we see that the relationship is curved, so it's a nonlinear relationship. A final thing to consider is whether there is any point that sticks out, what we call an outlier. In the next section, we'll show how these can be identified with a box plot, but in scatter plots, it's a bit of a judgment call. In this scatter plot, there's a point at 1.510 that sticks out. We'll look at how to deal with these points in the next section. Finally, you have a go yourself. Back to the MPG dataset. This scatter plot has the city fuel efficiency against the displacement. Describe that relationship. Seriously, pause the video, have a go. So, what's your conclusion? Mine's that the relationship is a moderate, negative, non-linear relationship. Do you agree? Think about if it passes the stupidity test. That is, does it make sense in context? Probably cars with bigger displacement are more powerful, but most likely to be less fuel efficient, so this relationship does make sense. Next, we'll look at the final relationship, quantitative versus categorical.